Hi everyone, today we're going to talk about the surface area of prisms. So when we talk about surface area, we're talking about the area of all of the surfaces. So in a three-dimensional figure, there are a lot of surfaces, and so we need to find the combined area of them. That's the surface area. So today, a prism is our first term that we want to start out defining. It's a polyhedron formed by two polygonal parallel congruent bases. So those bases are parallel to each other, they're congruent to each other, and there are two of them. And they're connected by lateral faces that are either parallelograms or rectangles. So what you see right here is a prism, a rectangular prism. And then off to the right side, you'll notice that it's kind of been unfolded. So we have side A, B, C back here, and D on the side. We've kind of unrolled this. And then we have our bases on the top and the bottom. So this is our net of all of the surfaces of our rectangular prism. Now over here, we have the same thing except for we don't have the bases. And so we're going to talk about how that's different and why it's important to not include the bases sometimes. So, the lateral area, sometimes called the lateral surface area of a prism, is the product of the perimeter of the base and the height. Now this piece should have gone down here. The lateral area formula for a prism is L equals, L stands for the lateral surface area, the perimeter of the base, capital P, times the height, lowercase h. So this is the formula for the lateral area of a prism. So if I find the perimeter of this base here, that's going to be the distance all the way across from the bottom of A to B to C to D. And then if I multiply that by the height of the prism, then I end up with this rectangular piece right here, that rectangular area. This is the lateral area. So we don't include the bases when we're finding the lateral area. It's kind of like if you think about a box or a can, it's like the wrapper, the stuff that goes around the outside, not on the top and the bottom, not the bases, but just kind of the sides. So that's the lateral area. The surface area of a prism is the sum of the lateral area that we just talked about in the previous bullet point and the area of the bases. So you add everything together. So this was lateral area, this is the total surface area. So the formula for the surface area, capital S equals the lateral area, which is the perimeter of the base times the height, plus, so the sum of these two, plus the area of the bases. Well, there are two bases, so 2 times the area of the base completes the formula for the surface area of a prism. So let's go to the next page. We have a little bit of terminology to discuss before we start practicing. So for our definitions, the base of a prism is not just the part that's on the bottom. The base of a prism is one of two congruent parallel faces of the prism. So if I have a pentagonal prism just like this, the base is not this part down here that we are kind of sitting on. The bases are these pieces right here that are the polygons. They are congruent to each other, they're parallel, and there are only two of them. So those are the bases. The lateral face is a face of a prism or pyramid that's not the base, or in other words, the sides. So if you stood the prism up on its base, then the sides would create the lateral faces. So down here, our lateral faces are these rectangles that you see, and there are 5 of them. An altitude is a segment with its endpoints on the planes of the base to the bases and is perpendicular to the planes of the bases. Perpendicular to the planes of the bases. And then finally, an edge is exactly what it sounds like. An edge of the three-dimensional figure is a segment that is the intersection of two faces of the figure. So it's where those two pieces kind of meet. So to discuss these pieces, this is what we call a right prism. We call it a right prism because the base and the edges that are created by these lateral faces, they're at a right angle to each other. So it's standing erect, standing upright. This is what we call a right prism. Like that. This up here is a base. This down here is also a base. This arrow is pointing to this piece right here. This is a lateral face. And then this right here is an edge. Now over here we have an example of a different kind of prism. This is called an oblique prism. We say this is an oblique prism and not a right prism because the edges that are coming off of the base are not at right angles to the base. So this is not a right angle. You kind of have to slide this out here to make the right angle. So an oblique prism has a base in place and then the top base is not situated directly over it. It's kind of slid over to the side. Notice that the bases are still parallel to each other and they're still congruent. However, they are not one right on top of the other. So that makes an oblique prism. At the bottom of the second page, it says the surface area of a cube with edge length S. Notice that all of the edges have length S in a cube because it's made up of 6 squares. So the surface area of a cube with edge length S, that formula is a little different. It's 6 times the side squared. Because in order to find the area of one of the faces, you multiply base times height, so side times side, that's side squared, and then there are 6 of these faces. Now in a cube, it really doesn't matter what the base is and what the lateral faces are, because you can kind of roll it over and it looks the same no matter what orientation you have. So the surface area formula is the perimeter of the base times the height, plus 2 times the area of the base. Well, it just so happens that the perimeter of the base is side plus side plus side plus side, so 4S. The height is S, plus 2 times the area of the base, which is side times side, that's side squared. So we have 4 times side, plus 2 side squared. So this is 6S squared. So that's the surface area formula for a cube. Now you can use the surface area formula for a prism, but once you input all of the correct values, you're going to end up with this formula all the time. So a cube is a little special. Let's go on to our last page of the notes that has our examples. Example 1 says find the lateral area and surface area, so both of them, of the right rectangular prism. So we know that this is a right angle and this is a rectangular prism. I'm going to go ahead and shade my bases. So here's a base and here's a base. The formula for the lateral area is the perimeter of the base times the height. Well, the perimeter of the base is 2 times the length plus 2 times the width. So 2 times 8 plus 2 times 6. 2 times 8 is 16, 2 times 6 is 12, and if I add those together, I get a perimeter of 28. The height of this prism is 12. So when I multiply the perimeter of the base, 28, times the height, 12, I end up with a lateral area of 336. Now we're measuring in centimeters, and this is still area, so this is centimeters squared. The formula for the surface area is connected to the formula for the lateral area. So the surface area formula is the perimeter of the base times the height plus 2 times the area of the base. So we already have this piece right here. That's 336. But now we need to multiply 2 times the area of the base. Well, the area of the base is just length times width, so 8 times 6. That's 48. 2 times 48 is 96. So 336 plus 96. And if I add those two together, I get a total surface area of 432. And because it's area, we're measuring in centimeters squared. So example 1 had the lateral area and the surface area required for a right rectangular prism. But problem B asks for the lateral area and the surface area, again, this time of a regular hexagonal prism. So we might have a little bit more work to do with this one. The lateral area formula is the perimeter of the base, right? Well, we know that this is a regular hexagon for the base. So down here, a regular hexagon means that all sides of this hexagon are congruent. So if this side is 6 meters, they're all 6 meters. And it's a hexagon, so 6 sides times 6 meters, and I end up with 36 meters for my perimeter. The height of the prism right here is 10 meters. So when I multiply those together, the perimeter of 36 times the height of 10 meters gives me a lateral area of 360 meters squared. When I calculate the surface area, which is going to be a little more involved, the formula, and I'm going to do it over here so I've got a little bit more space and I'm not wasting it. The formula is the perimeter of the base times the height plus 2 times the area of the base. Well, we have this piece right here. It came from the lateral area. So 360 plus 2 times the area of the base. But the area of the base is what we have to calculate. So we have a regular hexagon. I'm going to use the formula for the area of a polygon because this is a polygon. We know that this is 6 meters. So if I draw 2 radii and the apothem, if this whole thing is 6, then this piece is 3. This central angle is 360 degrees divided by 6. So that's 60 degrees. If I take out this triangle right here, if this whole angle is 60 degrees, then half of it is 30 degrees. That means this is 60 degrees. Short side is S. Long leg is S square roots of 3. Hypotenuse is 2s. So if the short side is 3, that means that this right here, the apothem, is 3 square roots of 3. And the side length here is 2 times 3, which is 6. So now I can find the area of my hexagon. It's 1/2 times the apothem times the perimeter of the base. So 1/2 times 3 square roots of 3 times the perimeter of the base. 6 times 6 is 36. Half of 36 is 18. 18 times 3 is 54 square roots of 3. That's the area of the base. So that's what I'm going to multiply by 2. Because there are 2 bases that I need to add together for the surface area. So my final surface area is 360 plus 2 times 54 is 108 square roots of 3. I can't add these together because they're not like terms. One has a square root of 3 and one does not. So I give them their units. I'm measuring this problem in meters, and because it's surface area, it's meters squared. Now, these are problems that talk about the lateral area and the surface area of a prism. Occasionally, you will have a problem that requires that you find the composite surface area. So the surface area of the composite figure. Composite, remember, means that we are composing it of multiple pieces. So in this problem, there are two prisms. Up top, we have a triangular prism, and on the bottom, we have a rectangular prism. And I need to find the total surface area. Now, something that may cross your mind is that I can't just add the surface area of the triangular prism and the rectangular prism, because I have this little piece on the inside where they meet that is not part of the exterior surface. So I'm going to have to subtract that out. So just keep that in mind. For the rectangular prism, my surface area is the lateral surface area, so the perimeter of the base times the height, plus I'm not adding both bases, I'm just adding this one base, because this one up here is in the interior of the figure, so I just want one base. So let's focus on this first. The perimeter of the base is 4 plus 4 plus 2 plus 2. So 4 plus 4 is 8, 2 plus 2 is 4, and if I add those together I get 12. The height of this rectangular prism is 3. And then the area of the base that I'm finding down here is the length times the width, so 4 times 2 is 8. So this is 36 plus 8. This is 44 centimeters squared. So that takes care of kind of this open box down here, this rectangular prism without this top base. Now we need to calculate the surface area of the triangular prism. So for the triangular prism, the surface area is equal to the lateral area, which is those three rectangles, so the perimeter of the base times the height, and then plus 2 base areas. Now we do need to subtract out this right here, which doesn't happen to be a base for this triangular prism, it happens to be a lateral face. So I'm just going to go ahead and subtract out that area, and the area of that rectangle is 4 times 2, so this is 8 square centimeters. So I'm going to subtract out 8. Now also keep in mind that for this triangular prism, the base is not the bottom. The base is the sides. So these triangles are the bases. So when I find the perimeter of the base, this is 3 centimeters. This is 4 centimeters, just like down here. And it is a right triangle, so if you know your Pythagorean triples, you know that the hypotenuse here and here, this is 5 centimeters. 3, 4, 5. That's a Pythagorean triple. So the perimeter of the base is 3 plus 4, which is 8, plus 5, which is 13. Oh, sorry, 3 plus 4, which is 7, plus 5, which is 12. The height is the distance between the bases, so that's this right here, and that's 2 centimeters. The area of the base, remember these triangles are the bases, and the formula for the area of a triangle is 1/2 base times height. So half of 4 is 2 times 3, that's 6, and I'm subtracting 8 from it. So we have 24 plus 12 minus 8, that's 36 minus 8, and that's 28. So if I add together my rectangular prism surface area without the top base and my triangular prism surface area without the bottom lateral side, then I'm going to end up with 44 plus 28, and that gives me a total surface area of 72 centimeters squared.